Good afternoon. I hope you all are having a awesome SQL bits. And what's the fun of a data conference without some AI spices sprinkled on it, right? So let's talk AI. Here we are going to talk about how to build AI application. And obviously, you will use your data to build AI application. To walk you through the journey with some good example and some good demos, my name is Sanjay Mishra, and with me, Muazma. And we are from the Microsoft SQL Server and Azure SQL team. And we build the product that you love. We are the problem if you are having any problem. So it's our responsibility to fix anything, our responsibility also to innovate so that you can be ready for your future. So how we are doing it? So the way we see intelligence in database and around databases, we think that, okay, the applications first the database must be intelligent. And you all have been using them because we have an awesome intelligent query processing service. We have serverless service which intelligently scales your database up and down. And then we have intelligent applications because now you can build intelligent applications on top of your data which takes advantage of the AI capabilities. And then intelligent operations so that your operations on the database, whether it is about maintenance of the database or it is about doing any kind of a troubleshooting on your database, and that should be intelligent as well. In this session, we're going to talk about the middle part, the intelligent applications. How to build intelligent applications on your data. And obviously your data is in SQL Server or Azure SQL, so this will all focus around building AI applications. Now, where does this intelligence come from? No data, no intelligence. As simple as that. All the people who came that they have intelligence, all the machines that they have came intelligence, it is nothing but accumulation and structuring of all the data over a period of time. So therefore, data is the breeding ground for intelligence. How many of you are data professionals, if I can ask? Awesome. You are the custodian of data. You are the custodian of the future intelligence. So absolutely. Now, what happens is that while in no matter what business you are, artificial intelligence is coming in and sparking a revolution, making a level playing field among all the competition. Whether it's a small customer or a big customer or a new customer or an old customer or a different region of customer, artificial intelligence is a disruptor. It is creating a level playing field for everybody. However, those who have the data, those who have the relevant data, those who have the most accurate data hold the power because data is the differentiator. And we are going to show you today how you can use actually your data to make your applications more intelligent, which even though right now what is happening, everybody has access to LLM, SLM, OpenAI, Closed AI, you name it. Everybody has access to those. Now, what is the difference between you and your competition? Is that you have access to your data and they don't. You know your customers, you know your business, and we're going to use them today. Before we go anything, the first thing first, Microsoft runs on trust, and that trust goes across everywhere, including how we treat AI. Either for building any AI model or fine-tuning anything, we do not use your data. Your data is your data, not our data. Your data stays where you are, and we give you the technology to harness that data to the best of your business functions. For building AI applications, there is a database is one component, but there are multiple layers of application components that actually helps build it. From the ground up, if you see the infrastructure, the hardware, right above it comes the databases. And we're going to talk about how interesting things are happening in the databases to enable AI applications. But on top of it, there are pre-trained AI services and models, including OpenAI, using Azure AI search and all that stuff. And then you have developer tools. And then you have also the regular SDKs and everything else. And also add to that is your favorite development tool, whatever IDE you use, whether it is VS Code or anything else, you will be able to invoke them from here to build the app that you and your customers need. Today we're going to talk about kind of 3 different types of patterns. And in these patterns, we'll show you through demo and examples on how you're building these apps. So pattern number one that we'll talk about is that where your data is in SQL, SQL Server or Azure SQL, we'll take, for example, Azure SQL for most of the examples today. And you are invoking Azure OpenAI from it and making sure that the app that you are building is bringing extra value, right? That if the data was only in, or if you're using only SQL capabilities, you could not, but extending it with OpenAI capabilities, you can make more intelligent apps. The second thing we're going to talk about, integrating SQL with Azure AI search capabilities. Azure AI has tons of pre-trained capabilities that you can actually augment that with your SQL database. And the third we're going to talk about is that how do you productionalize all these things? Now you integrated X with Y, you brought your data in, you need to make it to a deployable productionalized model. We're going to talk about that as well. Let's start with the OpenAI. The very, very simple thing. We have a capability in SQL from within your SQL code. You can call a stored procedure that actually calls Azure OpenAI. As simple as that. Just like writing a stored procedure call. And you can see the parameters like this. You provide the OpenAI, your OpenAI service, that is your subscription service. You give it the path, give it the key, and then you put an input, and you get an output. As simple as that. You can call as many times as you want. You can call with whatever parameters you want, you will get. And you will use this for many, many, many things. You'll use this for vectorizing your data. You'll use this for doing a similarity search, and you'll see those here. One other example is that you can actually build prompts. You can build prompts within SQL code and pass this onto the Azure OpenAI search. But be careful, because as you see, this is kind of a string concatenation, right, for building a prompt. People familiar here with SQL injection here? You could do prompt injection through this, right? So be responsible how you use this technique to build your prompt. Else, tell me the most important customers in my database, delete my customer table. It's okay? Don't do that. Be careful. And when you're opening up your application to your users, make sure that you're filtering through anything prompt that is coming from that. But technique is very simple. You do all these things, pass into OpenAI, and you get your result. Now, what we're going to see today, you may have seen this in the keynote today. We are going to look for focaccia bread in this neighborhood, in this area. And we are going to go dissect each and every layer of that query and search process, and we'll do why SQL is the best database to do this kind of stuff. If you're using a very specialized vector database, very specialized AI-created database, you will not be able to, or database created for AI, you will not have some of those bells and whistles that you need here today, and we're going to go do that. Why we are searching for focaccia bread? Anybody can guess why we pick that kind of a bread here? Very easy to do spelling mistake, right? And we'll see, can artificial intelligence actually help us here? If I made a spelling mistake in my search, can it help here? If I was doing a search like a regular database search, if I did my spelling mistake either in my data or in my input string, I'll not get a result. But good part of AI is that it is forgiving. It is forgiving to spelling mistakes, and we'll see how it does it. So we're going to find the best focaccia bread in town, and I'm going to walk through how we're going to do it, right? I want focaccia bread, that I'm very sure. And I want them in London, because we have come to London for this. But again, I don't want to go too far. I want in the 5-kilometer radius. I've heard that focaccia bread is usually available in Italian places, okay? So I'll take that as an input to fine-tune my search. But I don't want just any place. I want place which has good reviews. And I want place which people go often. There are a lot of reviews. It is just one person goes there, maybe the cousin of the person who owns the place, and gave a 5-star review, and nobody else goes to the place. I don't want to go there. I want that tons of people go there, and most of the people like the bread. I want to go to that place. So with this condition, I'm going to apply them to my tables. So I have data in 2 tables, and this is like I'm going to show you the actual tables, and like the millions of reviews from thousands of businesses are stored in these 2 tables. A business table where every business is information using their address, geographic location is stored so that I can do 5-kilometer radius search. And I also have a review where every business has got a review and it has been captured. And we're going to use them to give this filtering. Now see how to. This is easy in London. Very easy. If you use SQL database today, you do it every day. It's an equality search on the city column. Simple, easy, right? Next time, we're going to filter on good reviews. Again, there is a how many stars I have got. There is a column for stars. I'm going to simply do inequality search and do it, okay? Greater than 4. I'm going to good for enough reviews. There is a column called number of reviews, and I'm going to do a inequality search greater than 30 reviews, 40 reviews, 100 reviews, and I can do that. These are very simple. People do it every day, and this is your database is capable of doing this. Let's make it a little bit interesting. If I'm going to look for Italian place is actually stored as part of the categories column. It is a concatenated list of anything that the business have put there. They could have put a comma separate list, Italian, pizza, pasta, bread, focaccia bread, etc. They could have put it like that way. Or they could have put something else there. So I have to go parse that string using regular expression, which we announced today in SQL, right? Using T-SQL, you can do regular expression on a string, and you can actually find out if it has got Italian or not. Now, making it more interesting, so this is a regex search. Making it more interesting is 5 kilometers radius search, which means that I'm going to take geographic location where I am. It could be my phone application, right? So it needs to know where I am. The app you are building could be deployed on your phone finally, right? My location and the location of every business, I'm going to do a geospatial query on using that one. Now think of this. Some of these are possible with some databases. Many databases can do equality inequality search, mostly. Very few databases can do that, plus a geo search. And very few databases can do that, plus geo search, plus a regex search. The database that you all use does it. Feel very happy about it, right? Now guess what? We need to go a step further. All the reviews, the thing is that there is no menu here. So what do I sell? There is no menu here. The only way for me to find out if a business sells focaccia bread or not is actually embedded in the review text. And the review text is a pretty big text, n worker max. And it is like a free format text. People are okay. I went to this place, ate their focaccia bread, and it was good or bad or taste or whatever, right? And they could have spelled focaccia very differently than I will spell it or you will spell it. And that's where the artificial intelligence come into picture. Because we are going to do focaccia bread search on the review column, which is a long text field, and we are going to do similarity search here. It is not equality search. It is not a geo search. It is not a regex search. That's where the AI will come into the picture. Using generative AI techniques, we are going to do that. So that's why this background is super important, how we are going to do that. Now, combining these two, the regular search, that where clause that you always do using the relational algebra, that relational database are very capable of, augmenting that with a similarity search using Gen AI makes it hybrid search. And therefore, you don't have to take your data from SQL Server or Azure SQL to some other database that allows you to do similarity search. Because that's a painful process. Take your data from here, go somewhere there to do search. To find focaccia bread, by the time you would have gone and walked to go find focaccia bread and come back, right? Now, how we're going to do it? Let's see some actual code and videos. So I'm going to search, okay, what is this I'm going to find? I probably do not know how focaccia bread looks like. This is what it looks like, so I'm confident that, okay, what I'm giving is a good thing. Now that I found out what I need to search, 2-3 different types of it, here is my data. So data is stored in the 2 tables, and you can see that I have like 204,000 businesses, of which the review data and review like 8 million of reviews exist in my database, and I'm going to, so this is not a trivial data set. This is a fairly reasonable sized data set. On this, I'm going to do. The bigger the data set, the power of the relational databases come to the fore. Because now it can do early filtering of all those other criteria that you are not looking for. So with that, we'll see how can we go further next. And this you know, very simple as I was showing in the other, I'm going to just city like London, I'm going to do greater than 4 star. A bunch of record came back. But still, I'm not sure if I'm narrowing down all enough because I still don't know, okay, did I reach the Italian place? Am I within the 5-kilometer distance? So I'm going to add a few more predicates to my where clause. And one of them I'm going to put there is about the distance, because I don't want to go around hunting for this all over the place. And that is a geo-distance is possible only if the database supports geospatial data type and geospatial function. SQL Server and Azure SQL does it. Use it. And you can see, give a distance. So 5 kilometer, I've converted that into the format that it likes. And then I'm also adding this regular expression that some places they sell pizza or they call themselves Italian places. That's where usually focaccia bread is found. I have not yet come to focaccia spelling, so you can imagine that will come. So this is going to kind of bringing me very close to my set of searches. That means I have actually taken care of all my non-AI filter criteria. My regular relational database, relational algebra filter criteria is all done. Now let's try to do AI on here. Okay. Now what we are going to do is that now that we have found that you see most of them are bringing me to the right kind of restaurants. Now I'm going to do this. Here is the interesting thing that is new. We have, as I was showing you in the code, that we have a stored procedure to call OpenAI. This stored procedure actually get embeddings, actually calling that behind the scene, passing a place where to get good thick focaccia. See, I've done the spelling mistake there. Focaccia, I thought, okay, with my accent, I thought focaccia, C is. Marisha runs an Italian restaurant or used to run it, so she exactly knows what the right spelling of focaccia bread, and so she's laughing. Okay? Now, this is actually the code behind it. This code is calling OpenAI, passing whatever parameter I give it to it. I give my keys, my URL of my OpenAI endpoint, and it is going to create an embedding. Embedding is nothing but vectors, which is like a series of numbers, and comparing to give me a similarity search. By the way, all this code will be available to you. All the sample code will be available to you. The deck will be available to you, so don't worry about if it is going a bit fast. But what we did here is that all the relational algebra filters, we are augmenting that with a similarity filter, and that is giving you the final result of where can I find focaccia bread within 5 mile of radius in the city of London that has got at least 4-star reviews and it has got at least 30 or more reviews. So with that, I found out which 2 reviews are actually indicative of that, and I found that they actually have it. And see, the spelling is, and because spelling, people can make spelling mistake. They're focaccia, so that person to that, another person probably typed it. So this kind of my spelling mistake are forgiven. The spelling mistakes done by people who left review are forgiven because it can do similarity search. It doesn't have to be exact search. So augment your exact search from all your filter criteria with the AI given similarity search and find out the thing that you're looking for. Now that we know that, we got the reviews that we want. These are basically the 5 different things. Eventually what you want is that you care for the review, but you really want to go to the business that has that review. So let's go find the business which are the reviews. So this is from the review table. I need to go back, look at the business table so that I can go to the business, where is the location, and maybe call it Uber and go there. So what we're going to do that, we're going to concatenate all this stuff, find the business. In the next screen, you will see there. Okay, sorry. I jumped a bit. Okay. So then we combine all of them to give you which businesses have the focaccia bread. Any questions? Yes, please.
Can you not use AI to search on all of the fields instead of that specific one?
You could, but then it will not allow for, then you have to go find out. Okay, sorry. The question is, can you not use AI to find out what you're looking for? So wherever I can use equality search, non-equality search, or a geo search, and I showed you that. The review and the word focus here is part of a big text where there is a possibility of spelling mistake. So I need to look for anybody who has spelled anywhere closer to focus here, and I want to look for that. And that's why you need the similarity search of AI. You take advantage of the benefit that AI provides because it brings you not exact search, but similarity search. So the life is like this. There are certain things in life where exact information is needed, right? There are certain things in life where approximate information is fine, good enough. If I want to go somewhere, if somebody tells it is, yeah, about 4 miles or 4 kilometers, I'm okay with that. But if somebody wants to know somebody is having in the ICU and needs to get a medical record of some of the vital things, they need to know the exact, otherwise they may take a wrong decision based on that. So there are different fields of uses where non-exact information is actually useful. If I would have, because of the spelling mistake, and guess what? The best of the best review is where the best of the best spelling mistake is there. And if I had done the regular database search, I would have actually skipped it because it was spelled wrong. And AI kind of allowed me to include that in my result set. Make sense? Is there any online question? No, not yet. Yes, sir, and then I'll come to you.
The response that the store procedure is giving back, does it give you any confidence score or something that you will say that that is exactly your on the letter or something?
Good question. So thank you. So the question is that the stored procedure that we are getting the result for, does it give you a confidence score on that sense? Very good. So you can actually do that as well. You can ask the stored procedure. So that's the good part of calling OpenAI. You can actually ask OpenAI, give me the result in this format. What you choose, why you choose, what is your thought process, and is there any score about this one? It can actually do all this stuff. We have kept here just as a simple case how to augment that one, but very good question. You may actually, to take the application to the next level, you may want something like that. Good, thank you. Yes, sir. Okay. So the very good question is that the table has 8 million reviews. Does it mean that we need to make 8 million API calls? So there are two times the calls are made. Once we are making the call to do all the embeddings, vectorize every review at the beginning, which we have already done it. We did not do this in the demo. We have pre-done that because otherwise it will take time to do to 8 million. So that time you have to call for every row. That time you have to call for every row. We have done that and stored it in the database. Now when I'm doing this search, I'm only doing one call, and that call is my text string, because I'm giving, give me a place where I can find good focaccia bread, right? And who knows, tomorrow I may use the same data set, and I say, give me a place where I can find good chicken tikka masala, right? At that time, I'm going to send only that text, and that text is where I'm going to make the API call and come back. Make sense? Good, thank you. So now I'm going to actually walk through how we are actually doing that, because you people use relational databases a lot, so I'm going to explain that in this term, the step by step. So this is my original data set. This is where all the things are there. We have augmented this with embedding. This is what we do. Initially, we embed everything, so that no matter what you search, we have it. So that column is actually the embeddings column that you see, the blue color column. Now we got the search text. For us, it was give me a place where can I find good focaccia bread, and other filters. Like in London, 5-kilometer radius, 4-star reviews, etc., etc. Those are other filters. What I do with this, we take all the other filters, apply here, and get a subset of that. And what we do, the search text, we create an embedding for that. That's one call. To create an embedding for that, and compare that embedding with this, and then get the data set there from the business. Then what we do, basically we do a join of those two, and then we get the final set. And then you may do any kind of post-processing. That, okay, I need to combine all the reviews to give you the list of only the businesses that you're looking for, or anything else you want to add to it. But this is the whole application design that you need to do to achieve it. Okay. Good. Hopefully you liked it. I'm handing over to Mosma to take us through integrating SQL with AI search. Yes, sir, I will take your last question. Yes. Okay. So the question is there a size limit for the embedding column? Okay. So one thing I did not mention is that we just introduced, this is a sneak peek of vector capability within SQL database. You are hearing for the first time, nobody else has seen it. So, okay. So this is the, even before private preview. So this is as an initial offering. In the initial, we will have some limitations as we build this. But eventually, we're going to, by the time it comes to release time, we're going to make it capable enough so that most of the businesses will be able to handle the workload. But we're working on it. So stay in touch with us. I would like to take your contact so that we can give you the, when the actual preview comes, you can actually test it and tell us if it works for your business.
Yeah, just to add, I think the embedding part of it, if your question was about the embedding, so that would depend on what model you're calling. In this case, we're calling Azure OpenAI. So if there is a limit on the type of model, like we were calling GPT 3.5 Turbo, that was a very specific model. So the input text can be as much that model supports. So that's your prompt, right? And that is pretty much, I think it has 5,000, like like 20,000, like it's huge right now. So I don't think you will hit, you will get a review that long to hit that limit. But there are techniques around it. We're happy to chat about it. You can concatenate the data, do one time, multiple times, how you're storing it. So there's some limits that you can hit there. And the limits and functions is what Sanjay was talking about. Thanks for that question. So what Sanjay covered so far was the first pillar, right? So there are two other pillars. So those are the things that you can do today with SQL. But there's a whole AI ecosystem, as in one of the earlier slides he was showing, from the core hardware layer to the AI layer and how you bring your own models and things like that. So one of the options there is to integrate your SQL data with Azure AI Search. It used to be called Azure Cognitive Search. They have specialized models to do specialized work. So I'm going to show you a couple of demos that are built by one person called Brian in my team. You'll hear his voice in the upcoming slides as well. But on a high level, this is what the architecture looks like. So as your previous, the question you were just asking, like if your data is too long to fit it into any kind of AI model input or output, there's a process called chunking. Again, we have not spent a lot of time here to go into a lot of those concepts, but what Azure AI Search does, when you point it towards your SQL database, it does this chunking by itself. We actually released it in last November as a private preview, and it's going GA next month. What it will do, it has some, I would say, intelligence in it to figure out what is the right appropriate site to do that. From there, you have options. You can use Azure OpenAI service or any of the OpenAI algorithms. You can directly call to OpenAI. For example, if you don't want to use Azure, you can directly call OpenAI because some of our customers are telling that they already have OpenAI subscription, so they want to use their APIs. Or you can have a custom API. So if, let's say, you have a specialized model that is fine-tuned for your own use cases, you can actually call that as well. As long as you have an API to connect to it, be it REST or I think they're working on GraphQL as well. But if it's a REST API, you'll be able to do that as well. From there onwards, any application can access this. So earlier today, I showed a demo in the booth. You can use Azure AI Studio to do chat, so which is really chat with your data kind of scenario. Or you can build your own application. So this is where we see a good combination of your SQL data to build any AI applications. And I'm going to show you one very important scenario that we see. For example, one of the scenario that we see is around content moderation. So for example, you have a database where you are storing a lot of data coming from different sources. You want to make sure that there is nothing in the data that is not safe or can provide harm or other things like that. So there are these two specialized Azure AI search services. One of them is called Azure AI Language. The other one is called Azure AI Content Safety that you can actually use to augment your data or build intelligent application for these cases. Some of the use cases where this kind of scenario can be used that we have seen, for example, my favorite one is in the last one, which is in the education system. If you are providing, I have young kids, if they are on the internet, they're looking at some content, the apps can filter some of the information that the kids should not be seeing. There are many other use cases in gaming, enterprise, social media messaging. A lot of these, we ourselves actually do a lot of moderation on different places as well. So you can actually build this layer on top of your AI application for that. So this is one scenario, and let's see this in action. So in this example, what you're going to see in next few minutes is you will have the SQL database, which has all the data stored. There are somebody's SSN numbers, which is a social security number. I don't know what's the equivalent in UK, but there's not supposed to be publicly available. So you can actually use that. And somebody earlier asked about the confidence score. So in this, using the content safety, you can actually get the confidence score as well. And also you can analyze for any of the language, anything which somebody should not be seeing, and let's see that in action as well. So this is one scenario where you can augment your SQL data, build that into an AI application, in this case for content moderation. So let's see the demo. There's silence. Should start.
This video will showcase using Azure OpenAI with the Azure SQL database by calling REST endpoints via stored procedures inside the database. The first Azure OpenAI service endpoint being called will be the Azure AI language service. This service will analyze text and detect the language used, personally identifiable information, sentiment and meaning, as well as key phrase extraction and summarization. The stored procedure that is being created takes in 3 parameters: the Azure OpenAI endpoint server name, the API authentication key, and the block of text to be analyzed. Using Azure SQL's ability to call external REST endpoints from right inside the database, we can pass the parameters and text to be analyzed to the AI language endpoint with one simple procedure. Once the Azure OpenAI AI language REST endpoint's response returns, we can pull out the redacted text from the JSON payload using Azure SQL Database's built-in JSON functions. In the next SQL statement, we are parsing out an array of values returned by the endpoint for category, personally identifiable information, and a score of how confident AI language is with the analysis of the value. We will provide the REST endpoint with a block of text that contains personally identifiable information such as phone number, address, social security number, and IP addresses. The procedure is then executed by providing the parameters for the Azure OpenAI server endpoint, authorization key, and text block previously defined. The Azure OpenAI AI Language Service REST API returned the text block with all personally identifiable information redacted. The redacted result can now be inserted into a table stripped of all sensitive data in scenarios such as public message posts, product reviews, or any user-initiated input. Looking at the results of the second SQL statement, we see values containing the personally identifiable information the AI language service discovered, a category it believes it belongs to, and a confidence score pertaining to the classification and extraction of those values. The second demo will be using the Azure Content Safety REST endpoint. Azure AI Content Safety detects harmful user-generated and AI-generated text and images in applications and services. Content Safety can also be used for jailbreak risk detection, a feature that scans text for the risk of jailbreak attacks on large language models. Similar to the first example, this stored procedure accepts 3 parameters as well: the Content Safety endpoint server name, the API authentication key, and the block of text to be analyzed. And again, with one simple procedure, and using Azure SQL's ability to call external REST endpoints from right inside the database, we can pass the parameters and text to be analyzed to the Content Safety endpoint. Once the Content Safety REST endpoint's response returns, we can pull out the content category and severity from the JSON payload using Azure SQL Database's built-in JSON parsing functions. The procedure is then executed by providing the parameters for the Azure Content Safety server endpoint, authorization key, and text to be analyzed. Azure Content Safety analyzed the text, and the results are classified in a harm category. A severity score from 0 to 7, with 7 being the most severe, is then assigned to each category for further evaluation. For example, you could block an insert into the database if the score is above a 5. Do you want to try out this
So that was the link we'll share at the end. So this was one use case you saw end-to-end. So content safety as well as any of the things that you want to redact. So we call two different Azure Cognitive Search endpoints directly from your data. You can do it before writing it to your table as well if you have that kind of check, or you can do it for your front end. Thinking of any kind of use case that you have in your applications, this is one example of building AI-ready applications. I will take a question if anyone has any question at this point. We have one last section. Yes?
On you said that safety, this content is part of the cognitive search, right? Do we need to specify or feed this information in Azure subscription, or how do you set it up?
Yes, very good question. So the question is, this content safety is the endpoint that we call as part of the cognitive search. Do we have to feed this information of what that content safety means for us? So yes and no. So the service comes with the default, like there are 10, 15 categories and scores, and it has its own algorithm of how it does it. There's all the information you can find about that. What you do with it, the thresholds and how you work on that's completely configurable by you. You can also do, if you saw that in the demo, we actually added some additional information saying that these are the type of things I'm really looking for. So if there are particular words or particular things that you really want to make sure that they are like absolutely a no for you, you can add that as well. They also have an option to actually write a REST API call directly on Cognitive Service to enhance that. That's another option as well that you can look into, and I'm happy to share those links with you after this session. Okay, so we talked about two types of scenarios so far. The last scenario is one example that I wanted to show with LangChain. LangChain is an open source platform. It is known for building agents, and those agents are actually a task that you want to perform as a service. So a lot of people are using these AI applications and making them connected to any of the data source, in our case, SQL database, and then making it productionized. So you can make a full workflow of things. For example, if you take the previous example, you can take the content safety as the first part and then make it an agent. Then once that is done, you want to do something else. For example, the use case that Sanjay had for a similarity search, and then do something else at the end. So it becomes like a workflow completely for them and for you, for your app. And then you can take it from one environment and deploy it into production or any test or any pre-production environment as well. It is very easy to set up, so we're going to show you one quick example of that as well. So the way to work it, make SQL work with LangChain, there is this LangChain toolkit. We are actively working on enhancing that and making more and more simple. It's basically based out of our Python driver, and you can use any of your frameworks like SQL Alchemy. In the demo that we have here, we will use that. And you can make it more context aware. So you can make it more context aware based on your SQL data. So in this example that I'm going to show again, the demo that was done by Brian, is connecting the SQL data to LangChain. And I'm, in this case, using an NL to SQL. So in this session, we wanted to show you the art of the possible with different types of scenarios. What we are going to do here is to do a natural language communication to your database through an agent. And this is not the SQL agent, as some of you are aware of. This is the agents in LangChains that you can create with SQL data. So in this case, you can say, invoke the agent and pass the question like, for example, count the number of rows in XYZ table. And then the LangChain agent will go and figure it out where the table is, will do the count for you, and can return it. So just using a natural language, you can communicate with your data and do different operations on it. So think of this of one example of how you can use these agents in your production workloads or applications. So let's watch this demo as well. I'm realizing there's some
Delay?
no, we initially had music in the beginning, but.
Okay.
This demo is going to show how you can use LangChain to create a natural language to SQL agent against an Azure SQL database to ask it questions about your data. To start, we need to prepare our environment by installing the required Python packages and libraries needed to run the notebook. The ODBC driver for Microsoft SQL Server needs to be installed so we can contact the database via the LangChain agent. Provided in the notebook are the SQL statements to create the table and insert values into the table for you to use with the LangChain agent later on in this notebook. To store sensitive information like passwords and keys for OpenAPI endpoints, we use a .env file or environment file. This ensures that these sensitive pieces of information are not in plain text within the notebook. The last setup that needs to be done is to make sure that a Python kernel has been selected for running the notebook. Let's start the demo. The first piece of code we're going to run is going to set up the environment for running our Python code and loading in those sensitive pieces of information from the environment file to be used later on in the notebook. Using SQL Alchemy, we create a database engine from the connection string in our .env file. We then test that connection by using some built-in functions like getting all the table names we can see, as well as running a simple SQL statement such as getDate. This example uses Azure OpenAI as a large language model to be used with our SQL agent. Here we create a reference to Azure OpenAI utilizing these parameters as well as parameters found in our .environment file. The last step before we talk to our data is to create the SQL agent. As you can see, we are referring to the LLM we created previously as the Azure LLM. It's time to test the agent. Here we're going to invoke the agent with a natural language question and see how it arrives at the answer against our Azure SQL database. The question is count the rows in the lang table. Here we can see it went through step by step, found a table, created the SQL statement, ran it, and gave us the answer that there are 10 rows in the lang table.
So this was one example of, again, using an agent to do a natural language type processing on the data that is stored. In this case, we were using the actual metadata to do an action of counting the table. You can actually do other things. For example, if you don't want to read-only access, because this one actually ran something as well, you can do that as well. So there are many different scenarios you can do. So the last thing I wanted to show, and we wanted to show you here, is what we talked about in this session so far is the left-hand side, right? So it's the AI component. Most of the real-life applications are not as simple as just adding an AI component to it. So you have your own set of other things that you already are doing in your applications. For example, you might have API layer, so data API builder in front of it, which is reading and writing the data, either GraphQL or REST, through your database. You have your client apps. You could be doing it in Azure Static Web Apps or self-hosting it. You could be using Azure Functions. For example, the moment data lands, you want to do trigger binding on that data, go to content safety check on that, and then insert the data or update the data. So thinking of the whole application infrastructure is very, very, very important. So wanted to show you that it's just one part of this big AI-ready applications that you all are currently owning or thinking about building as well. If you want to learn more about one of those such examples, so we have this session recommender example. This has been used at 3+ or 4+ conferences already, where we have built this whole thing with one-line command with AZD, and you can deploy it, test it. If you have one of the similar data sets, you can actually test this out as well. So that sample is today available. With that, these are all the resources. The most important 2 resources that you should definitely check out, and this is something we'll be updating very regularly, is the SQL AI and SQL AI samples. The first one will take you to the docs page. The second one is where we are placing a lot of our samples. But all of this architecture that I talked about, be it the data API builder with containers or how you add AI to it and all of those blogs are hosted in this first one, which is the Azure SQL Dev blog. My team regularly posts about it. We also allow others to co-author stuff. So if you have a cool or some application that you're building, please reach out to us. We would like to know that, publish those blogs with you or samples with you as well. SQL Dev and also the Azure SQL blog page as well. So with that, this is the last slide, I believe, where if you are a data developer and you want to be part of what we are building and provide us feedback, want to learn more about what we are doing, this is the link to go sign up. We are actively looking for feedback. This is a field where every single day there is a new model out there. There's something new happening. So we are also trying to learn from our customers and users. What are you seeing? How are you building these these applications, and go from there. So definitely sign up, and we will be in touch. And that is all. So for this session, any feedback? We will have, I think, 4 more minutes for any questions. So let's take a few questions.
So before the question, I have an offer. So if any of you are building any cool AI applications on SQL, next conference, I want you to be on stage with us, talking about your applications. This conference or any other conference, any user group online or thing. So bring it to us, bring it to our attention that, hey, I have this kind of data, and I have this kind of user requirement, and we built it. Be our guest, join us. So
anyone here is building an AI application that would like to share their scenario? I have 1 pair of socks of swags that I can share. And stickers. Okay, any questions? Yes?
yes, please.
So the question is the new vector data type in SQL, when that would be available?
So yeah, let me try to address that. So the vector inside a database takes 3-4 shapes. One is the vectors themselves, and you could store the vectors in any kind of data type of your choice if you want. And then, or you could store them actual vector data type. The second component of it actually the functions. That okay, I'm comparing one vector with another vector, either the cosine distance or a dot product distance, all different kind of functions, so that you can call from your T-SQL code to those functions. The third one is that okay, how do I make those super efficient through indexing and stuff like that. So first, what will so the demo that you saw today is based on vectors, not stored in vector data type though. It will be stored in a vector in a var binary. So var binary store doesn't allow you to see you as a vector, but allows us to do all the operations as a vector. And the functions that you saw today are based on that. And so first you will see the vector stored as var binary and those vector functions. Then you will see the actual vector data type. And then eventually you'll see the vector indexing as well. But your question was when? It is in our pipeline. Cannot tell you the timeline yet.
It's soon.
Coming
I
soon.
can say
so
it's
you
very
saw the
soon.
sneak peek today. So it's baking. The focus separate is baking. It will come soon.
It's very soon.
There was one more reason why we choose focus separate, because it's baking. Any more questions?
Yes.
So can these things work on premises? That means, or do you have to migrate the database to SQL, Azure SQL, and then run all this stuff?
Yeah, I can take that question. So the external REST endpoint invocation process.
Repeat the question.
So yeah, the question is, can these things work on on-prem, or do we have to migrate to SQL in the cloud for that? So the external REST endpoint is coming to MI soon. It will be announced soon. And then it will come to SQL Server as well. The vector, we are currently working on SQL DB as the first platform, and all the capabilities there. We are thinking of coming up in the next SQL Server release as well. So whenever the next SQL Server release comes, that's on our roadmap. No guarantees at this point.
Okay. So yeah, if you can add to that, is like Azure SQL database is like a Uber service. You call it and it is there, right? Whereas the SQL Server is like a scheduled flight between the two big cities that you go to. It is scheduled, it will come in a number of months and years time frame. So for us to get to the customers first, it is easy for us to get in the Azure SQL database. So first this thing will show up in Azure SQL database, and slowly it is going to show up in all flavors of SQL as well. Whether it is a particular type of data type, it is a particular type of API call, it is a particular data type of indexing, that's kind of our release mechanism. Want to use it today? use in Azure SQL database. Today, very soon it will come.
Yeah, just last comment with AI search. AI search is capable of connecting to any on-prem server, VM, as long as your firewall rules, you can set those up. So if you are doing anything with AI search, the part of it that I showed, that you can do today with on-prem as well. Thank you.
Thank you.